Hello friends, I am Professor Zakatdar and I am always after my most favorite three topics. I am passionate about three M's. First M is mathematics, second M is motivation, and third M is music. I am passionately following these three hobbies of mine, and this is the first hobby that I am going to expose in front of you. And I am interested in telling you one story first of all. In our childhood, there was a lesson in our regional language. That lesson had one character. He used to forget everything, And for example, when he first time he went to the school, at the right time. Every time he was late. But that day, he decided that I must go at the right time. So at 7 o'clock, exactly 7 o'clock, he reached the school. What happened? The school was closed because he had forgotten that it was Sunday. Next time, the college lecturers, the school teachers told him that all of you are going to be engaged in a workshop where you will be given a piece of land and you will be growing certain vegetables. Okay. Now, you will be given seeds, you will be given this, you will be given all the material that is required to grow the land, and within 6 months, we want that all of your farms will grow that particular vegetable. Okay. And if you can do that, you will be graded according to the quality of your work. This fellow, because he is feeling so guilty, he says, no, this time now I am going to put all the efforts beyond other students and I am going to make my project successful. So, he went on there every day. He started watering the plants. He started putting best of the vegetables, best of the fertilizers, and started waiting for the plants to grow. But after 6 months, what happened is other people's plants were growing. There was no plant at all in his farm. Why? Because he had forgotten to put the seeds in it. Now, what is the lesson we are going to learn out of it? The entire plantation is based on a foundation of growing seeds. If you plow the field, inside that there is a foundation of the plants, and that foundation of the plants are the seeds. If there are no seeds available, the plants are not going to grow. And why I am telling you all this? Because in my experience, whenever the student pass standard 10, which is a laborious examination, which taxes them very much, and there is a lot of pressure on them. And in that examination, they have studied so much that in the 11th standard, they tend to take, holiday. A study holiday, because it's not a board examination. They feel that it's a college examination, I need not study. But the problem with this entire structure is, you are going to study mathematics, physics and chemistry in 11th standard, 12th standard, first year engineering, second year engineering, third year engineering, fourth year. This entire 5 years building of mathematics, physics and chemistry is based on the foundation which will be created in 11th standard. And if you neglect that 11th standard, it's like forgetting to sow the seeds only. If you are not sowed the seeds, how the plants will grow? So I want you to be very, very particular and pay a lot of attention to the foundation of the higher mathematics. Because higher mathematics starts, its beginning, its foundation is in 11th standard mathematics. Now, 11th standard mathematics is going to be responsible for the entire building, or the stubbornness or the stoutness or the longevity of the building called mathematics in your career, right? And if you are going to be an engineer, you have got to be 101% good in mathematics, because without mathematics, there is no technology. Without technology, there is no engineering. So please, 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 I request all the students that keep all your doubts aside, keep all your fears aside, because I am there to help you and make it interesting and understandable, right? Just be with me, relax, and just listen to what I am saying. And of course, after the lecture is over, please ponder over the lecture Please do a lot of thinking and find out, is there any gray area in my lecture which you have not understood? Fine. Just talk to me on my email, Talk to me on my email. At the end of my lecture, I'm going to give you my email address. Okay? Is that all? Thank you. Now, see, traditionally, if you look at the tradition of mathematics in its history was divided into two parts. One is called algebra. And the other one is called geometry. These two parts of the mathematics developed in the different parts of the world. Geometry was developed in Greece and all Western countries. It started with Euclid, as you all know. Geometry deals with figures. The basic unit of geometry is point, lines, figures, curves. So these are the topics with which geometry deals with. Okay, whereas algebra deals with numbers. So here the basic ingredient is numbers, and here it is point. So geometry is based, the fundamental point of geometry is point itself, and fundamental point of algebra is numbers. In algebra, you add numbers, you subtract numbers, you divide numbers, you create polynomials out of them, you solve the polynomials, you solve equations. All these operations come under the banner of algebra, and algebra was developed basically in Indian subcontinent and Asian part. I mean, China as well as India was responsible for developing algebra, whereas geometry was being invented in the Greece and European countries basically. Now, there was no connection between the two. Just imagine, I cannot draw numbers, I cannot trace numbers, whereas I cannot add points, I cannot subtract points, I cannot multiply points. So the operations which are basically necessary in algebra are useless in geometry, and the operations which are geometrical operations are useless in algebra. So there was no connection between the two, and for thousands of years people thought that they are two separate branches. In fact, they were not collectively called mathematics at all. But there was a great invention. There was a mathematician, philosopher called Descartes. He created a magical revolution in the world of science. Had it not been for him, this technology would not have been possible. Today's life, the luxuries, and the kind of life that we are enjoying will not be possible unless this fellow was not born. What he did, he basically combined the two things. He made them together, combined it, and created another kind of geometry which is called coordinate geometry. What he did was amazing. He took a geometrical problem, converted into algebraic problem, solved it by using algebraic technology, and what happened? Geometrical problem is solved. Conversely, he took an algebraic problem, converted it into geometrical problem, solved it, and the problem is solved in algebra. Now this was a revolutionary technique, and both the techniques we are going to study this year. We are going to study, for example, coordinate geometry. But I told you, coordinate geometry is nothing but a bridge between geometry and algebra. So, in order to understand coordinate problems, we will have to understand algebra first, right? So, first we will understand algebraic techniques. And the basic unit of algebra is what? Numbers. So, we will deal with numbers first of all, and then we will develop algebraic machinery in such a way that it can be applied to geometry, and geometrical problems can be solved by using the algebraic machinery which we have mastered. Okay? This is the basic of any kind of higher mathematics. Just imagine the application of this. For example, just imagine that there is a meteorite and Earth is moving and the meteorite is also moving. And you do not know whether that meteorite is going to hit the Earth or not. Right? Suppose you know only geometry, you can only find out a trajectory that this is how it is going to move. But whether the trajectory will meet the earth or not, that you cannot decide. As a physicist, what will you say? I do not know. Let us wait and see, watch what happens. But if you use coordinate geometry, you can just write down the equation of a trajectory and equation of the trajectory of this earth and find out whether they intersect each other or not just by writing certain equations on the piece of paper. And then you resolve the problem. If you find that there is a solution, then the meteorite is surely going to hit the earth. Otherwise, it's not going to hit the earth. And that is done simply by solving certain equations. So basically a physical problem converted into geometrical problem converted into equations, and solving equations gives you the solution to the problem which will save the earth from its extinction. That kind of power this kind of mathematics has, and we are interested in laying down the foundation of that kind of mathematics which has created this entire world of technology. Now, in 11th standard, what kind of algebraic techniques we are going to learn? So, algebra, as I said, algebra. First of all, as I said, numbers are the basic units of algebra. So, we'll talk about number system. Secondly, we always talk about a group of objects. Group of objects means we collect certain objects which are well defined and then we talk about their common properties. So always mathematics ka language jo hota hai, wo always in terms of groups, and those groups are called sets. Collection of objects, as it is called. So you collect certain objects, you describe them in such a way that you exactly know which objects are to be included and which are to be excluded. Once you do that, then it can be called a set. For example, set of alphabets, set of vowels in the set of alphabets. So you know A, E, I, O, U. So it's well defined. So you know what connection we are talking about. Set of birds. That means all those animals who have got wings, So this kind of thing. So this is a basic language of mathematics. That is why then we'll learn sets. After we have learned sets, we'll go slightly advanced in the number system and we'll talk about complex numbers. You all know that a square of any real number is always positive. If x is positive, then x into x means positive into positive, so it will be positive. So if x is positive, then x positive, again x positive, their multiplication will always be positive. If x is negative, if x is less than 0, then x multiplied by x is negative into negative, that is again positive. Correct? So therefore, square of a number is always positive. So if you come across a negative number, does it have any square root? That's a very fundamental question, puzzling question. And for thousands and thousands of years, people just could not think about this. They thought this kind of thinking itself is irrational and nonsensical, so did not pay any attention to that. But there were mathematicians who were brave enough to deal with this problem, and they created a new mathematics called, new numbers called complex numbers. After we have learned the simplified form of complex numbers, we are able in a position to understand another equation called quadratic equation. Quadratic equation. Quadratic equations forms the foundation of many branches of mathematics, particularly all the curves that we are very familiar: ellipse, parabola, hyperbola, circle, point, line. Everything can be expressed in terms of a quadratic equation. So study of quadratic equation is at the root of coordinate geometry. If you understand quadratic equation properly, if you understand how to find out solutions of the quadratic equation, you will be very successful in dealing with coordinate geometry problems. Okay. After quadratic equations, we just slightly, deviate from this kind of a thing, because there are other parts of mathematics which are also simultaneously must be developed, and that is called determinant and matrices. And matrices. Now, there is a very interesting story about determinants and matrices. Matrices is what? Matrices is actually a table of numbers, like this, A, B, C, D, E, F, like that. Now, there are numbers. In place of A, B, C, there are certain numbers. And this is a table of numbers. Now, there was a mathematician called Hamilton who always hated the application of mathematics to physics. Because in his time, the entire mathematics was developed out of the need of physical sciences, that is physics basically. He wanted to create a mathematics which is not applicable at all. Now, very strange requirement, but he was behind it. So he created a new algebra of table of numbers, and he called them matrices, and then he decided the laws of adding them, subtracting them, dividing them, whatever. All kinds of mathematical operations he applied. He defined them, and he was very happy that I have created a completely new branch of mathematics which has no application at all. But had he been available today, had he been alive today, he would have died 1,000 times. Why? Because today, the most applied branch of mathematics is matrices. Everyone in the world nowadays keeps on looking at the screens. This world is made up of screens. Half of our living time is spent on looking at screens. So there are screens everywhere. Your mobile has a screen. Your laptop has a screen, your television has a screen. And what is this screen? This screen is made up of pixels. There are rows and columns of pixels, and those rows and columns or pixels contain information about whether it is to be lighted or put into dark. So all that information becomes a matrix of a table of numbers, and those table of numbers are called matrices. And unless you understand matrix operation, all these images which we see on the screen will not be able to possible or will not be able to move itself. So then we go to another topic called permutation and combination. Today's world is full of, technology which is basically based on the ideas in this particular field. For example, thousands and crores of signals are being sent from one mobile phone to another mobile phone. How many signals are getting created and traveling all over the world across? We do not know. Billions, trillions of them. But they don't get mixed up. Why they don't get mixed up? Because they have a particular pattern, and this pattern is decided by permutation and combination. It's the beginning of a science called combinatorics. And in computer science, this is the fundamental branch of communication. Okay, so in order to make our talk invisible to others, in order to codify it, So coding theory is the basic. This coding theory is basically springs out of this mathematics called combinatorics, and then we deal with a last part that is called probability. Probability was created out of a very bad habit called gambling. But later on they realized that it has got a lot of applications in other fields of the human endeavor. And later on they were stunned to find that even quantum mechanics or physics, everywhere we need what? Probability. So we talk about probabilistic happenings, So we are going to build the fundamental foundations of probability in 11th standard. That is why I am emphasizing again and again and again and again. If you understand 11th standard mathematics, you are sowing the seeds of a very powerful plant. Okay. So this is the algebra, and this is the algebraic machinery that we will need to develop what? Coordinate geometry. So then we go to geometry, coordinate geometry, in which we'll study coordinates of points, then we'll study lines, then we'll study circle, then we'll study conic sections. So these points will be associated with an ordered pair called xy. Lines will be associated with equations. Circle will be associated with equation. Conic section will be associated with equation. In other words, all these geometrical figures will be converted into what? Algebra. And this algebra that we already learned we will be able to solve it. So you can see the combination of geometry and algebra, and the foundation of that is going to be built during this year. Apart from this, of course, there is another part of mathematics that we are going to learn. Now, this part of the mathematics is developed because of the requirement in physics. In physics, what we do? In physics, we study the motion of objects. You know, how the objects are moving, how the astronomical objects are moving from here to here, or why the stone falls down and doesn't go up, or how the rockets are flying. Chandrayaan kaise gaya? You know, all these problems are there, physical problems, and for that we need another science called calculus. Now, what is calculus? Calculus is a study of change. There is one variable y and there is another variable x. Now, if x changes, then y will also change. Now, as x changes, y will change. So, we want to find out how fast or how slow the change is taking place. If you heat water and if you heat milk, the water will rise, the temperature of the water will rise faster than the temperature of the milk. Why? Because of its density. So, therefore, we want to find out how fast the temperature is rising. So, there is a function called f. So, we arrive at a function called f dash, and then again we go backwards from f dash to f. So, this is f, this is f dash, and this entire process is called differentiation. And then later on, we'll reverse the entire process. From derivative, we come back to the original function. This process is called integration. In the simplest term, differentiation is like a division, right? And integration is like a multiplication. So they are inverse operation. So once we have learned differentiation, we'll also learn what is integration. And after learning integration, we'll apply it to the real life problems. So that is called application of derivatives and applications of integration. And once we have done that, the foundation of the higher mathematics will be complete. And I am guaranteeing you that all the fundamental concepts involved in entire algebra, entire coordinate geometry, and entire calculus will be taught to you within a very short time. Just follow my lectures and always remember and think about my exercise to all the students here is, after hearing my lectures, if you have any questions, please direct those questions on my email address, that is pmzakatdar@gmail.com. Don't bother about your questions, whether the questions are good or bad, rational or irrational. Whatever troubles you is a question that I'm looking for, because your questions will allow me to level my learning, teaching, and it will be like a feedback mechanism, and it will help each other, so that my next lecture will be dependent on your responses. Thank you very much.